Welcome to the science class. Today we are going to discuss about chapter gravitation. Previously you have already learnt about the motion of objects and force as the cause of motion, isn't it? Because of force, object moves or a moving object stops. We have also learned that force changes the direction and the speed of any moving object. We always observe that an object dropped from a height falls towards the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, how they are moving around, how they are not changing their place. Why is it so? They change their place in accordance with another stationary object. For example, earth changes its position but sun is stationary. Again, moon also revolves around the earth. How is it so? What makes them move around without any disturbance? So there must be some kind of force which is keeping them in a particular direction, or we can say a particular orbit, isn't it? This force is called the gravitational force. In this chapter, we shall learn about the concepts of gravitational force. Okay? We will also learn the universal law of gravitation. We shall discuss the motion of objects under the influence of gravitational force on the earth. We shall study how the weight of a body varies from place to place. We shall also discuss the conditions for objects to float in liquids. Okay? So, students, we know that the moon goes around the earth. An object when thrown upwards. You can imagine you are facing same situations in our day-to-day life. Think about a cricket ball. When we throw it upwards, okay, the player comes under it and catches it. How come it doesn't go to the sky? Why it comes back? When you throw any stone upwards, it comes back, isn't it? So, an object when thrown upwards reaches a certain height and then falls downwards. It is said that when Newton, the great Sir Isaac Newton, was sitting under the tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So, it must be attracted by the earth. But we do not really see the moon falling towards the earth, do we? Yes, we see the earth moving round the sun. We see the moon, it moves round the earth. It never comes towards earth or it never falls on earth. Neither earth falls on the sun. Otherwise, there would have been a destruction overall, isn't it? So, why is it so? Let us try to understand the motion of the moon by recalling the activity that is 10.1, which is given in your book. You can do this activity by yourself. What you have to do? Take a piece of thread, tie a small stone at one end, hold the other end of the thread and wheel it round. Note the motion of the stone. Release the thread. Again, note the direction of motion of the stone. Students, you can clearly observe that when you wheel the stone with the help of the thread, it moves round and round, isn't it? You can try it by yourself. It moves round and round. The stone never falls. It is attached to the thread and you can feel the circle round and round, having your fingers at the center. The thread, it moves round. The stone never gets back. It never goes out of the orbit. But When you leave the thread, what happens? It goes in a certain direction. It goes in a certain direction. It doesn't keep on moving round and round. Why is it so? Before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. Isn't it? We know the rectilinear motion, isn't it? Motion in a straight line. So, if a body is not forced to change its direction, it moves in a straight line. Same way, the stone could have moved in a straight line, but as it is changing direction, so some kind of force is acting on it while it is moving. That's why it is changing direction each and every time. So the change in direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. Okay. So the force is coming from the center. It is applied on the stone and it is pulling the stone inwards. It is pulling the stone inwards. That's why it is maintaining an orbit rather than going in a particular direction. If that force would not have been there, the stone might go on a straight line. But because it is being pulled towards the center, that's why it is changing direction at each point and maintaining a circular path. This force is called the centripetal force or center seeking force. The force acting towards the center. So it is center seeking force. So you can clearly observe through this activity that in the absence of the force, the stone flies off along a straight line. This straight line will be a tangent to the circular path. So what is a tangent? A straight line that meets the circle at one and only one point is called a tangent to the circle. So as given in your book, you can clearly see that straight line ABC is a tangent to the circle at point B. It touches only the point B. It does not touch any other point of the circle. Okay, that's why it is a tangent. It touches only and only a single point of the circle and it is a straight line. Okay. So students, the motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. That means moon would have been somewhere else. We couldn't have seen the moon as well because it could have been somewhere else. But as earth never let it go away, it pulls the moon towards itself. That is the centripetal force of the earth that pulls the moon. That's why it is a centripetal force. It acts towards the earth. By this force, moon is being forced to move round and round and round. So this uniform motion is your uniform circular motion. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple. Why? So think about it. If there is some force of attraction between two bodies, that means apple is also pulling the earth towards itself. So it might have happened that without doing anything, we might go up to the apple and pluck it and eat it. But it never happens. Why is it so? According to the third law of motion, the apple does attract the earth. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. The mass of the apple is negligible, small compared to that of the earth. So though there is a force of attraction, because the mass of the apple is very, very low in comparison to the mass of the earth, we do not see the earth moving toward the apple. Extend the same argument for why the earth does not move toward the moon? Same thing, because moon has a very low mass in comparison to the mass of the earth. That's why though there is a force of attraction between themselves, both apply force on each other. Moon moves around the earth, rather it moves and moves in a circular motion. Earth never goes towards the moon. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the planets and the sun, but as the mass of the sun is very high than the planets, that's why planets move around the sun. The same force, the centrifugal force, acts between the sun and the planets. Okay? From all these facts, Newton concluded that not only does the earth attract an apple and the moon, but all objects in the universe attract each other. This force of attraction between objects is called the gravitational force. Okay? So students, let us discuss the universal law of gravitation. Okay? So every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. For this, let us concentrate on the diagram that is given on your book, and let me draw the diagram for you so that we can discuss it in a better way. Okay? So students, I have drawn the diagram as it is given in your book. Okay? Let the two objects A and B of masses m and m lie at a distance d from each other. That means let mass of A is equal to capital M and that of B is small m, and the distance is equal to d. Fine. So the distance d is from the center of A to the center of B. Fine. Let the force of attraction between two objects be F. So let the force be F. So the force of attraction that lies between A and B is F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of the masses. So according to that, the force of attraction between A and B, that is F, is directly proportional to the product of mass of A, that is m, and mass of B, that is small m. Fine. And the force between two objects is inversely proportional to the square of the distance between them. So let it be equation 1. Again the force is inversely proportional to the square of the distance between them. That means 1 by d square, because d is the distance between two objects. Let it be equation 2. Fine. So when I combine these two equations, we get an equation that is F is proportional to m by d square. Fine. And we can write that implies F is equal to g m by d square, where g is nothing but the constant of proportionality. Okay? Here g is the constant of proportionality. So we have found a formula for the gravitational force between two objects, that is F is equal to g m by d square, where g is the constant of proportionality. Okay? So students, this g, which is the constant of proportionality, is also called the universal gravitation constant. By multiplying crosswise, okay, let us see what happens. we multiply crosswise and find f d square is equal to g m m. F into d square is equal to g m into m. This is after cross multiplication. Okay. So, students, we have found out that f into d square is equal to g m and m. From this, we can have the formula for g, that is g is equal to f d square by m m. Okay. So, the SI unit of g can be obtained by substituting the units of force, distance and mass, and that is N for force, that is your Newton, d square meter square divided by mass, okay, that is kg square, because mass and mass, kg into kg, that is kg square, which can be written as n m square kg whole to the power minus 2. So, this is your SI unit for gravitational constant. Okay. The value of g was found out by Henry Cavendish by using a sensitive balancer. So, the accepted value of g is 6.673 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Okay. So, this is the accepted value for the gravitational constant g. Fine. We know that there exists a force of attraction between any two objects. Compute the value of this force between you and your friend sitting close by. Conclude how you do not experience this force. The law is universal in the sense that it is applicable to all bodies, whether the bodies are big or small, whether they are celestial or terrestrial. Okay. Students, as there is given in your book about inverse square. What is it? Let us discuss. Saying that f is inversely proportional to the square of d. Okay. So, inversely proportional, f is inversely proportional to square of d. That means 1 by d square. What does it mean? If f increases, d decreases by its square. If f decreases, d increases by its square. So, if d gets bigger by a factor of 6, suppose d gets bigger by a factor of 6. Okay. So, f becomes 1 by 36 because square of 6 is 36. So, it is getting bigger. That is why force will get smaller. Understood? Because they are inversely proportional, and as distance gets bigger by factor of 6, force will be smaller by its square inversely. What is the square of 6? 36. Inverse means 1 by 36. That means if one is getting bigger, the other will get smaller with the square. Hope you understood this. So, students, let us discuss example 10.1. It says the mass of the earth is 6 into 10 to the power 24 kg and that of the moon is 7.4 into 10 to the power 22 kg. If the distance between the earth and the moon is 3.84 into 10 to the power 5 km, calculate the force exerted by the earth on the moon. Okay? keeping gravitational constant as 6.7 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Okay, let us discuss. Fine. So students, let us discuss the solution for example 10.1. It is given that mass of earth m is equal to 6 into 10 to the power 24 kg and that of the moon is 7.4 into 10 to the power 22 kg. And the distance between the earth and the moon is given as 3.84 into 10 to the power 5 kilometer. So these are the given data, and it is also said that take the gravitational constant g is equal to 6.7. It has rounded up the value to 6.7. Okay, 6.7 into 10 to the power minus 11 Newton meter square and kg to the power minus 2. Fine. So students, let us convert the distance into meter. Okay. So d is equal to 3.84 into 10 to the power 5 kilometer. That means 3.84 into 10 to the power 5. That means 1 kilometer is equal to 1000 meter. So 10 to the power 5 kilometer is 10 to the power 5 into 1000 meter. Okay. This gives us 3.84 into 10 to the power 8 meter. Fine, because 1000 is 10 to the power 3 and we know that by applying the exponent and power rule of addition, 10 to the power 5 into 10 to the power 3, that gives us 10 to the power 5 plus 3, so 10 to the power 8. That is why 10 to the power 5 into 1000 gives us 10 to the power 8. Okay. So hope you have understood how this distance is converted from kilometer to meter. We have found out the formula for force, that is F is equal to G m by d square. So we have all the values with us. Now by putting those values into this formula, we can find out the force. So that is equal to G, it is 6.7 into 10 to the power minus 11. Okay. Newton meter square kg to the power minus 2. Again your m, that is mass of the earth, that is given as 6 into 10 to the power 24 kg and that of moon is given as 7.4 into 10 to the power 22 kg divided by d. So d square is equal to 3.84 into 10 to the power 8 meter. That means it is the square value, so we have to square it. So force is equal to 6.7 into 10 to the power minus 11 Newton meter square kg to the power minus 2 into 6 into 10 to the power 24 kg into 7.4 into 10 to the power 22 kg whole divided by 3.84 into 10 to the power 8 meter square. So this gives us the value 2.01 into 10 to the power 20 Newton. Fine. So this is the force. This is the force exerted by the earth on the moon. Okay. This is the force exerted by the earth on the moon, that is equal to 2.01 into 10 to the power 20 Newton. Okay. Hope you have understood this. Students, with this we have come to the end of this session. In this session we have discussed some of the concepts of gravitation. In our next class we will discuss some more concepts about gravitation. Till then, go through your book, revise the concepts which we have studied today, and we will meet soon again. Okay? Keep smiling, keep practicing.